Hello, we are presenting sensitivity of Goldmann intraocular pressure measured by standard and CATS modified Goldmann prisms, predicting progressive retinal nerve fiber layer loss in treated primary open-angle glaucoma. Disclosures are as listed. In this study, we evaluate the relationship between Goldmann intraocular pressure measurement by standard and modified CATS corneal correcting prisms in progressive retinal nerve fiber layer loss in patients with primary open-angle glaucoma. It was a retrospective cross-sectional cohort study examining a database of 1,927 eyes, which had same-day standard and modified Goldmann prism measurements on at least 3 visits. We found 148 patients which met the inclusion criteria of primary open-angle glaucoma with at least 5 sequential quality optic nerve OCT measurements. Same model and version standard spectral domain OCTs were obtained. Standard conservative criteria for the diagnosis of primary open-angle glaucoma was maintained. 575 paired standard and CATS modified prism measurements over an average of 4.9 years were also obtained. The linear regression of retinal nerve fiber layer loss was calculated, and demographic CCT as well as corneal hysteresis were obtained on each patient. The Pearson correlations of retinal nerve fiber layer loss to IOP were compared between the standard and CATS modified Goldmann prisms. The CATS prism was found to be nearly twice as sensitive to retinal nerve fiber layer loss. This analysis indicates an IOP measurement of greater than or equal to 22 millimeters of mercury with a modified prism is 2.57 times more likely to demonstrate significant retinal nerve fiber layer loss than the standard prism at the same intraocular pressure. We also examined the paired difference between the standard and CATS modified Goldmann prisms of pressures taken at the same time. We found that for every 1 millimeter of mercury difference between the prism IOP led to a 0.66 microns of increased retinal nerve fiber layer loss per year. Of interest, we also correlated the retinal nerve fiber layer loss to corneal hysteresis and found that each 1 millimeter of mercury decrease in corneal hysteresis led to a 0.48 microns of increase in retinal nerve fiber layer loss. This correlation remains significant when IOP was included as a covariate. Including all covariates listed from the demographics and measurements, the CATS modified prism measurements always maintained a stronger correlation to retinal nerve fiber layer loss, as did the paired difference between the standard and CATS IOPs. Interestingly, CCT was not a predictive variable in retinal nerve fiber layer progression. In summary, higher IOPs led to more retinal nerve fiber layer loss. Surprise. However, a CATS modified Goldmann IOP predicts glaucoma progression by RNFL loss better than the standard Goldmann IOP. Benchmarks of 22 millimeters of mercury are much more predictive of loss with the CATS IOP. Lower corneal hysteresis significantly predicts increased retinal nerve fiber layer loss, corroborating prior studies, and CCT was not predictive. The takeaway is don't miss the boat. IOP is the primary indicator of glaucoma risk and glaucoma progression. With a simple alteration in the Goldmann prism, we can better predict loss from ocular hypertension, glaucoma diagnoses, and glaucoma progression. Thank you.